Hi guys, so last lesson we talked about tree diagrams, and if you weren't able to do that one, I will go back and do it. It's a pretty quick lesson, and this is basically going to be our shortcut to tree diagrams, because if you draw a tree diagram, sometimes they can get really big, and we don't want to have to do that. So to start, we're going to talk about some vocabulary, independent versus dependent events. So in probability, if you perform two or more events, so if you're like rolling a dice twice, or you're drawing two cards, okay, that's more than one event. These events can either be independent or dependent. So independent events are if the occurrence of one event does not affect the likelihood that another event will occur. So some quick examples. If you spin a spinner and you roll a dice, what you spin on the spinner is going to have no effect on what you do on the dice. They have nothing to do with each other. They just don't affect each other. So that would be independent. Another example is if you pick a marble, then you replace it. That's a keyword. And then you select another marble. Okay, if you replace it, then you're keeping that same amount of marbles in the bag. So that first event is not going to affect the second event. If you do not replace it, that's where it changes what could happen on the second draw. Okay, and that becomes dependent. So dependent, think you depend on what happens first, so that's why they affect each other. So if the occurrence of one event does affect the likelihood that another event will occur, those are dependent. And this is kind of the key to this one. If you see these words, you know it's dependent. So you pick a marble out of a bag, do not replace it, and then you select another marble. Okay, so if you're taking a marble out of the bag, when you go to draw the second marble, you've changed your choices. So there's one less choice for you to look at. So those become dependent because it depends on what you drew first. So if you replace it, or they're just two separate things, those are independent. And then if you do not replace, that automatically makes it dependent. Okay, so let's look at a few examples, and we're just going to label independent or dependent. So if you roll a dice, then you flip a coin. Okay, is the dice going to have any effect on what you do on the coin? No, so those are independent. Okay, you select a pair of socks out of a drawer, do not replace it, then select another pair. Okay, so if you do not replace it, look at your keywords up here. Which one would that give you? Dependent. I can spell, there we go. You select a card out of a deck, you replace it, okay, and then you select another. So your choices the first time are the same choices you have the second time since you replaced it. So those are independent. You randomly select a person in class to lead a group, then you randomly select another person. So I wanted you to think about this one a little bit. So if you randomly select a person in class to lead a group, can you choose that person the next time to lead the second group as well? Okay, no, you can't. So when you pick that person to lead a group, you're not putting them back in your deck of choices or your group of choices. So this is basically saying you do not replace. Okay, because that person's already an option, so they're not an option the second time. So that is dependent. Okay, because if I choose Mark to lead group 1, I can't choose Mark again to lead group 2. So what I choose in the first one affects what happens in my second choice. Okay, so look for those keywords. It should kind of follow one of these examples here to determine if it's independent or dependent. All right, and then the other thing we're going to look at today quickly is kind of our shortcut for independent events. Instead of drawing tree diagrams, we can actually just multiply our probabilities together, and it'll tell you the probability of the two events occurring together. Okay, so to find the probability of two independent events occurring together, you multiply their probabilities. So if you want to draw a red and draw a blue, you would multiply the probability of drawing a red times the probability of drawing a blue. So you just figure them out separately and then you multiply them together. So think about that last lesson where we talked about the fundamental counting principle. In order to find the total number of possible combinations, we had to multiply the number of possibilities for each event. So that's kind of what we're using. We're just also using the probability with it, okay? Because it tells you all the possible combinations instead of listing them out, and then you multiply them together as well. So let's look at a few examples, and that will be it for your notes today. So you randomly draw a marble from a bag containing 2 red marbles and 5 green marbles. You put the marble back and then draw a second marble. So you can see 2 things are happening, okay? And since we put the marble back, that's independent. So find the probability you draw a red and then a green, okay? So we want the probability we draw a red and then a green, okay? And the key word on these is you'll always see this and. Okay? So what we need to do is kind of using this formula here, we need to find the probability of drawing a red, and then we're going to multiply it by the probability of drawing a green. Okay, so probability of drawing a red, so we have 2 reds out of 2 plus 5, so 7 total. Okay, so that's the probability of drawing a red, and then we want the probability of drawing a green. So we have 5 green out of still those 7 total. And then we're just multiplying these together. Okay. Now, if you have a calculator, you can obviously just type that in. But if you're just using your phone, you just multiply straight across. So you do 2 times 5 is 10. And then 7 times 7 is 49. Okay. And if it simplifies, you can simplify it. I don't believe this does. Okay. So we'll leave it like that. And I put both answers on the Google form if you simplified or didn't. Okay, so number 2, an aquarium contains 6 male goldfish and 4 female goldfish. You randomly select a goldfish, replace it, and then select another. What's the probability of selecting a male and then a female goldfish? So we want the probability of getting a male on the first time and a female on my second draw. Okay, so again, we just find them individually and then multiply them together. Probability of getting a male, so how many males do we have? 6. Okay, and then we have 10 goldfish total because 6 here and 4 here. So 6 over 10 times, and then the probability of getting a female, well, we have 4 female goldfish, still out of 10. And since these are independent, those numbers will always be the same. Okay, so multiply across. 6 times 4 is 24. 10 times 10 is 100. So you can leave it like that, or you can simplify it to 6 over 25. Okay, so let's do a few more just different scenarios here. These were mostly things you were drawing out of, so I wanted you to see a few different things as well. So I don't have a whole lot more, but we'll just look at these. So you spin a spinner below and then you flip a coin. So those are my 2 events, spinning a spinner and flipping a coin. Find the following probabilities. Okay, so letter A, probability you get a blue. So that's talking about on the spinner. Okay, and so these blue are the shaded ones here. So we have 1, 2, 3, 4, 5 that are blue out of the 10 sections total. Okay, we're still multiplying. Now, getting a heads has nothing to do with the spinner. It has to do with our coin. So what's the probability of flipping a coin and getting a heads? Well, there's 1 heads out of the 2 sides, so it's 1/2. So these are going to look a little bit different because we're doing 2 separate events. You're not doing the same thing twice. Okay, and then we just multiply. So 5 times 1 is 5. 10 times 2 is 20. So 5 over 20, or 1/4 if you want to simplify that. All right, and then letter B, find the probability of getting a 5 on the spinner and then tails on your coin. So how many 5s do we have on our spinner? Just 1, so that's 1 out of 10. Okay, and then we're multiplying it by the probability of getting a tails on our coin, which is 1/2 again. And then we multiply. So that gives me 1/20. Okay, so that's another type of question where you just have two separate events. So just look at them separately and then multiply those fractions together. All right, and then the last one, this one looks pretty similar to our tree diagrams, just so you could see why this is a good shortcut here. So there are 3 t-shirts you want to choose from, 2 pairs of shorts, and 2 pairs of shoes. If you randomly select an outfit, find the following probabilities. So find the probability, and this one has 3 things, of a white t-shirt, khaki shorts, and Vans shoes. Okay, and we can do 3 things. We just multiply all 3 of them together. Okay, so we need to look at them individually. So find the probability of getting a white t-shirt. So out of our t-shirts, we have 1 white out of 3 total. So that's 1 out of 3. Okay, we're multiplying. Probability of getting khaki shorts. So looking at our shorts, we have 1 pair that are khaki out of our 2 choices. So 1 out of 2. And then the probability of getting Vans. So we have 1 Vans out of our 2 choices. So 1 out of 2 again. So we're multiplying these 3 together. So 1 times 1 times 1 is 1. 3 times 2 times 2. So that's 6 times 2, or 12. Okay, so it would be 1 out of 12. Now, if you had created your tree diagram like the last one, you would have seen those 12 choices. But this is just kind of the shortcut, is we can just multiply those 3 together, and that will give me that 112. All right, and then the last one, find the probability of selecting a red shirt and gray shorts. So red shirt and gray shorts. So just look at those individually. So probability of getting a red shirt. Okay, we're looking at these options. So 1 out of 3. And we're multiplying. And probability of getting gray shorts. So 1 out of 2. And then multiply those together, and that gives me 1/6. Okay, so use the multiplication rule on your Google form, and they should look pretty similar to these. Let me know if you have any questions, and you can redo it if you need to.